It was January of 2020. I was in my third year of PhD. One day in the lab, I saw a new face, a visiting scholar from Canada. His name was Moji, and I was given a task to show him around Cambridge. So we headed out. I remember it was a sunny day. I know, UK, January, sunny, sounds suspicious already. But believe me, it was sunny. We ended up at the cafe in front of King's College, talking, like all good PhD students, about our research. Because let's face it, as PhD students, we didn't have anything else going on in our life. Moji's PhD was on developing a new material for carbon capture. I was always skeptical of carbon capture. So I asked, Moji, why do we need carbon capture when we have renewable energy? Moji looked slightly annoyed, wrote down these three numbers. 22% of the global CO2 emissions comes from four industries: cement, steel, petrochemical, oil and gas. In these industries, CO2 emission is embedded in their process, and they cannot simply reach net zero with just renewables. Moji continued that carbon capture is currently too expensive. It costs $55 to capture 1 ton of CO2, and 66% of that cost is associated with two things: material and energy. Then he showed me his material, lime loop, that works like a sponge and soaks up CO2. It can capture 36 times more CO2 over its lifetime than natural limestone, which cuts the material cost by more than 80%. But he still didn't know how to reduce the energy cost. I told him, Moji, I might have a solution for you. I explained that my PhD is on heat battery. Moji looked confused. What is a heat battery? I explained a heat battery converts electricity into heat, store it, and turn it back into electricity. Moji looked even more confused. How does that help me? My answer? 4 words: carbon capture heat battery. I explained that when you expose lime loop to exhaust gases, it captures CO2 and releases heat, which we convert into electricity. Later on, we use cheap electricity to regenerate lime loop, so it can capture CO2 again. As long as the electricity we buy is cheaper than the electricity we sell, we're not just capturing CO2, we're making money from it. This idea excited both of us and led to founding Remedium. And it all started on that sunny day. Since then, we have shown that through our innovation, we can reduce the cost of capture to just $13 per ton. We have tested lime loop for 100 cycles, reaching TRL 5. We have built a demo of our carbon capture heat battery, reaching TRL 4, filed 2 patents, participated in multiple accelerator programs, won international awards, and secured a letter of intent. And just beyond the low cost, we deliver food-grade CO2 sold at $150 per ton, and our process is waste-free because lime loop is turned into cement after its lifetime. Our long-term goal is to build carbon capture plants through joint ventures with engineering firms. But to get there, we need to achieve 2 main milestones: scale lime loop production and build a pilot plant. In short term, our plan is to sell lime loop to companies that are currently using natural limestone for CO2 captures. And in medium term, our pilot plant can be sold as a standalone modular heat battery for high-temperature heat storage applications. This phase approach generates early revenue while enable us to advance the 2 aspects of our solution, de-risking our path to a full-scale carbon capture market. Our team presents a balance between experience and expertise. We have 3 PhDs, 2 MBAs with more than 90 years of accumulated experience in relevant research, industry, and startup. And over the next 2 years, we need funding to achieve 3 things: manufacture lime loop at ton scale, do a live flue gas test of lime reaching TRL 8, and demonstrate the battery at kilowatt hour. By the way, here's a photo of me and Moji on that day. You see, I told you, it was sunny. So now tell me, what do you do on a sunny day in January? You step outside so you don't miss it, right? Same applies here. If you're interested, let's talk. Thank you.